Welcome everyone to Tech Uncensored. Today we're talking about the distributed ledger. This is the future. This is the underlying structure for how we communicate, how we share, how we verify information, how we transact, or is it our future? So adoption for distributed ledger, or what some people call it, the blockchain, has been slow, but it's been synonymous with what we see in the emergence of Web3. Here we have a promise of equity, we have a promise of access. This is where there's going to be more accountability within a shared governance framework. And it is in an ecosystem that actually self-organizes. My name is Hessie Jones, and today we're seeing a lot of issues happening in tech where centralized authority in big tech has actually perpetuated some of the risks that we see today in identity, in manipulation, in data privacy. So this actually may be the ticket to give some individuals some semblance of control in a more democratized framework. And I'm happy to speak today to Dr. Jacob Mendel. He is a seasoned veteran of blockchain technology, and he served as a managing director for Blockchain Institute in Tel Aviv University. And he's currently the head of digital cryptography and cybersecurity at State Street. So Jacob understands this technology, and he can not only speak to the security, but also data privacy and the integrity of the infrastructure as we see things evolve. We'll also start to explore the work that needs to be done in the emergence of generative AI and the concerns about computational load and the sustainability of our systems as sensors become a lot more prevalent. So welcome, Jacob.
Welcome, good morning, good afternoon, and good night, because people all around the world, we need to touch everybody.
That's right. And Jacob is joining us from the UK, by the way. So let's start with your experience in this space. What has led you to venture down the path of blockchain or distributed ledger?
Excellent. So before answering all your questions today and the audience question, I just want to clarify a very clear disclaimer that everything is related to Jacob, okay, and the discussion and my personal experience in this, and not related to any firm, any organization, not currently today. Okay, so it will be clear.
Perfect.
I think that the technology of distributed ledger become fascinating because the different future use cases that we are seeing in the world, and especially even it's not any more sexy world, Web3, touch me the way it's going to change the economics, is going to change how we are dealing with identity, is going to change the way we are using data, and we are using our own data, is going to change everything. If the underlying technology of distributed ledger will be what we are using today from different companies and names which are running all around, and I can mention few of them, for example, Ethereum, Solana, Hyperledger Bezu, or anything else, it's not what is we are currently discussing. This is an evolving technology. What we need to look is how we are improving what we have today, what we are going to benefit from this. Why should organizations consider and listening to what we are doing now? Is it going to gain more money for them? They will be more efficient. They are going to get better service to their customer. The underlying technology can change. Today we call it DLT, distributed ledger technology. Tomorrow we will call it maybe Hyperledger something or another name that I don't know. Or it will be, we need to focus what we gain. Why should we look on this? And the idea that we can reduce the intermediators, all these between things which are just accepting from one side, add more cost, make delays, and then transfer it to someone else in the chain, and another one like this, and another one like this. And in the end of the day, you're getting it very expensive, slow, and no one really contribute any additional value in the process. Why we need all of this? So if there is a possibility to make business directly between party A and party B without the mediator. And they really can trust each other without knowing each other in the past. This is the idea. If person A can sell a car over the web to a person B that they never met, never, and he transferring the money, and on the other side, he gets the asset to the other party with the full trust of the system without need a lawyer, two lawyers, okay? Party A will bring his lawyer, party B will bring his lawyer, and the lawyer will get authorization from the seller and the buyer, and they will do the agreement, and you need to trust your lawyer, he need to trust it. You understand what we are talking about here?
Exactly.
We want direct connection, and this is what we are doing. And behind the direct connection is not to make this trustable transaction, is how we verify the identity, that I really sell something that I have. All of this are enabled on DLT, and this is why it's fascinating. And I said that this is a change almost the revolution that the internet brings to the world.
Okay, so it's more than just a cool technology, and it's actually going to solve some of the problems that we've seen in Web 2. So let's talk about what some of those problems are that in the current centralized structure.
The thing that people are thinking today on Web 2, we are getting a lot of services for free. No. You're not getting these services for free. The majority of services that you are getting for free on the Web 2 today, you are giving your privacy for this. And this is why you think you get it for free, but no. And sometimes they provide them personal information, what we call PII, and they give you these services. And you live with that. The idea is that the Web3 will give you the possibility of controlling, and the DLT is part of this, of the control of your own data. You, with a smart contract, for example, will be able to manage your PII information, to whom you want to disclose it, how they are going to use it, and only they will be able to consume it. And in some cases, you can even get money for it. Why to give it without money? So this is the idea and the fundamental change behind the scene. And also is that your data always remain at your side. That means you do not provide it to a third party. And now the data is already on their database. What you can do, you can ask them very nicely, can you please delete it? The data on Web3 will remain on your side. If you operate properly, okay? But the idea is the services will be with cost. Or you get money or you pay, but things are very clear on both sides.
Okay, so you've mentioned something there that I think a lot of people would find of value, because the essence of the distributed ledger is the smart contract. So can you explain a little bit how the smart contract works?
Okay, the smart contract is a software. In the end of the day, it's software. Very basic, very simple. If you go to the terminology and the language syntax, you will see that it's a very old technology concept of programming, very, very simple one. But the idea behind that is that part of the consensus algorithm and the next stage of the algorithm of the blockchain is to execute this code. And I want to explain something. When you are running a code, for example, on your laptop, when you run PowerPoint or Excel, you run it locally. And this is your own code. If something goes wrong with your code or someone manipulates your code, it will influence only you in that case. In the blockchain, the code is equal to all parties. The code is transparent. Everyone can see the code. Everyone knows how to interface with the code. The code that you will run for you and me using the same smart contract will be identical. All the condition, all the parameters, all the interface, and based on the input, you will get the relevant output. But part of the execution of the next stage, it will run also the smart contract. And this is part of the nice thing around that. So it's not that it's running in some cloud environment, or it's the same code running for everybody, and you cannot modify the code. It's not, you can put another smart contract, but again, the code will be identical to everybody which have access to this smart contract. And this is the most important thing around that.
Okay, so can you provide an example of this, how like data flows within a distributed ledger, how it's governed, and how the smart contracts will work? So can you give an example of how this actually works in a real environment?
Yes. For example, let's take an example that you have a medical record, and you want to share this medical record with insurance company. Okay. Now, the insurance company come to you and say, I want to get your medical records to give you an offer for your medical insurance. You will have all your medical information in a file, and then this file will be part of your database. Now, what is happening? You will decide what you want to open in your database to share with the insurance company based on the agreement that you have with them. And you will decide and specify for your smart contract, this is the terms and condition that I open my database to the insurance, to the specific, this insurance company, not everybody, not anyone, only this one. And the smart contract will negotiate with the entity or the smart contract of the insurance company based on the term and condition. They will match each other, and then they can share the information and execute. So the insurance company will ask my smart contract, execute or search this, display how many incidents happen, or this what are the blood type and everything. And the smart contract will negotiate with the other smart contract based on the term and condition. It's not that the database will be transferred. No, he will query my database, my smart contract will check, give the response about that. Another small example,
okay.
so you will understand that it's coming also from another, is the energy, for example. Imagine yourself, you have a smart meter. And the smart meter, you will program it a smart contract inside saying the following. Always prefer to buy energy from a utility company which are green. Even the price, and this is the range price that I want. If we don't meet this range, you can go to standard carbon or not green energy and take this for payment. And this is the margin or the boundaries that I'm willing to pay. And the smart meter will do it automatically for you, always checking the prices between the different vendors and select it according to the priority in the smart contract that you define. And the utility company can always scan and challenge who wants this, and they can make really a trade. Who wants to pay for this? I'm providing, and everything done automatically in the background for you.
So like from this perspective, because of the amount of automation that's already happening, it's very targeted to the terms and conditions of this contract. And so from this perspective, it looks like there's much more efficiency that's built into a system that I guess in the past has been, I guess, controlled by humans who have to be organized about, especially if that vendor we've worked with before. In the future, it's less about, okay, everybody, this is my example, send me an RFP if you want to vie for a certain position. Those who have been accepted in the past probably will not have to enter all that information again because they've done it before. But through like the past applications, they could essentially augment or modify what they've done. Is that what we're going to see in the future?
Hopefully, because this will be the efficiency and the reducing the cost and better services to all of us around the world, from governments, from different company of services, that we will have smart contracts acting on behalf of us. And in the back end, we will have our own wallet, digital wallet, which manage our digital asset to the different activities. And it can be from personal perspective and companies which do this on a regular basis. If you're talking about RFIs and RFPs, then there will be a smart contract which dealing and searching for such activities, combining, of course, a lot of machine learning combination around this, which will bring better quality, better connection, better business, and closing this together between two smart contracts.
Okay. So why do you think it's been difficult to actually move to this environment? It's still out there. But it's still slow. Mainstream hasn't evolved. Like obviously big tech was trying to move there, and they've run into their own hurdles. What's it going to take for us to actually move into a decentralized structure?
I really need to say thank you very much for asking this question, because this is something that not only I'm sure the audience are interested about that, but also the community around distributed ledger want to understand when the break will happen, when it will going to blow up and make the change. It's not a simple, the question is very clear. The answer is involved with multiple parameters. It depends, first of all, that this technology is a complex technology. It's not simple. And there is not a lot of people which really understand the underlying technology. And to deploy it, it's not straightforward. It requires expertise. And it's not available in the wild. It's not like, for example, if you currently looking for a Python programmer, you will get tens of thousands CVs just that you are looking for a programmer. Publish that you are looking for a Solidity programmer, someone which is expert in blockchain. How many you will get? How many really understand this? You will see, and companies doesn't like to make a change or enter into a new technology in early stages. They prefer, let's others start with this, and I will come later after I will see that this technology is mature. And this is why it's taking time for new technology to enter. And we are in this phase. The blockchain technology is not mature yet. We are seeing quite a lot of issues from different angles, especially in the cybersecurity. And don't forget, we have also the crypto. And crypto, unfortunately, mainly today in the mindset of the people in the audience and everybody around the world connect to criminals, bad actors, hackers, especially around ransomware, because they are paying with crypto, and the connection between them create a negative impact, negative thinking about. They hear the word blockchain. This is Bitcoin. This is the Bitcoin. The hackers are paying with Bitcoin. This is how criminals are transferring money. Boom. I don't want to touch it. Not in my company. This needs to change, and it will take time. And in parallel, the evolution will go forward to make it much more stable, much more mature, that companies can really understand, if I move to this technology, what it will save me, what I will gain from it. Why should I invest on moving this? Why should I go now in the university and learn blockchain? Why should I do this? When we have a clear answer to those, DLT will be in the main.
Okay. It seems like there's a lot of hurdles, though, that, that's going to make it more difficult for adoption. Like I'm looking at even the risks to our own electrical grid. So we know that blockchain is very much dependent on computational power and therefore electricity. But now we're also seeing the same thing of generative AI, like the amount of computational power it costs to actually run these large language models is now going to compete for the same power that's going to be used for a blockchain. Do you agree with that?
Again, this is exactly, the answer is in the question, because at the beginning, part of the evaluation of the technology, there was a lot of demand for energy for computation. But you can see that the thing is changing. For example, in Ethereum, we move from proof of work. We change the consensus algorithm. Okay, so when you move from proof of work to proof of stake and proof of authority, immediately you reduce the problem of high energy consumption.
Can you explain the differences between the proof of work?
Yes.
Okay.
Yes, of course. In proof of work, there is a mathematical challenge that the nodes in the blockchain need to compute before the next block is written into the blockchain. This mathematical challenge involves an algorithm called hash function, where the nodes are challenging between the network nodes about finding the nonce which will generate the signature, for example, that the hash of all the aggregated data in the Merkle tree will have at the beginning, for example, 6 zeros. This is only a forward calculation that when you calculate this, it requires the investment to calculate all the different possibilities. And you can split it between different nodes that select the ranges, each one of them to accelerate, but later you split the reward between all the participants. This is a heavy computation to do. Why? Because you need that it will be practically very, very hard to break it. Okay, I'm saying very, very hard, and I'm not saying impossible to break it. I'm very careful here to make it impractical to break it from this perspective. So this is why it required so massively computation. When we move to, for example, proof of stake, we change the model. We do not have a mathematical challenge. Every participant which are currently going to participate on setting up the next block in the chain will stack. That means will put in an environment that is not able to touch the asset, the crypto in that case. And based on the number of stacking that you will put, when we select a random number, the probability of selecting this node to calculate what will be the next block in the blockchain is higher. So, for example, if we have 4 parties, one will put 2 coins in the stacking, the other one will put 4 points, and the third one will put 6 points. When you calculate a random number, the one that put 6 and the other one which put 4 and the other one which put 2, divide this, the probability will split between them based on the number of stacking. So the node which put 6 on the stacking will have likelihood more chances than the other 2 which just put 2 and 4. Okay, this is how it's calculated.
Right.
Still, it's random, but the likelihood is relatively to the stacking that you put in the system. But this is also the commitment. When you stack something, you are putting your own money. The node put the money from his pool into this mechanism, so he cannot use it. This is his commitment to execute and calculate the next block in the certain amount of time that he got previously to do this. And he must do the calculation, otherwise he gets a penalty.
Right.
For this.
So that from that perspective, it's almost like he's putting his own integrity at risk because he has now skin in the game to be able to execute on that next block versus before where it was more of a competition. Is that what you're saying?
It's the skin is real money. It's tokens. It's the real token. It's putting it there and it's locked. So if he doesn't do something, the money is already not in his hand.
Okay, so let's talk about this from a security perspective, and is this really going to change how data is managed today, because obviously there's tons of mishandling of personal information, and now it seems like the distributed ledger will require more security protocols. Do you agree?
So one thing that I want maybe to break some misconception. Blockchain is not a magic word or a magic technology that solves cybersecurity problems or solve privacy problems, or both of them. Absolutely not. In some cases, blockchain create more problems on cybersecurity than other solutions, and create more problems on privacy and violate privacy than other solutions. But if you know how to do this correctly, and you know how to create the full system architectures to make it secure and to take care for privacy, then most likely you will build a much stable, secured solution. Now, this is like any other technology. If you don't understand the technology and you don't know how to configure it correctly and implement it correctly, you will find yourself very fast in the front of an attack that in a fraction of a second take your entire digital asset. Nevertheless, how much money you have. Nevertheless, what are the digital assets behind that? If you didn't implement it correctly, you are gone. You are gone so rapidly. And this is also why companies are afraid to jump into it so quickly. They said the risk here is too high for us. And they don't have the expertise and the knowledge how to really create a secure environment around it. So they have the trust to put all their technology, all their asset in this environment. And yes, we are seeing quite a lot of hacking happening in this domain, which create bad impact for this. So you really need to know what you are doing. And security and trust are going hand by hand in this technology. So I really recommend anyone considering entering this area, or even build a POC with real digital asset around that. Nevertheless, if this is crypto, NFTs, or anything around this, know exactly what you're doing.
No, exactly. Okay. So at least me to my last question, because what we're going to probably see in the near future, if we're not already seeing it already, is the rise of Internet of Things. We're already seeing some semblance of that in AR and VR. We're seeing it in smart watches, maybe Google Glass, or whatever iteration of it will be in the future. And so we're going to see much more sensor technology within the supply chain. And so it seems like in the future, if we head down this path, it needs to be within a framework that's trustworthy, as you call it. How do you think it's going to interplay with this emerging technology, in addition to what eventually will be artificial general intelligence?
When we are trying to combine IoT devices with blockchain technologies, one of the fundamental gaps that we have is Oracle. That means how we really can connect the sensors values, whatever they are bringing, temperature, telemetry, anything that the IoT devices are doing, how we can put them, the data that they bring, into the blockchain. The idea is not technically how to do it, how we can trust what the IoT device is creating, that we can put it on the blockchain. Because the moment we put it on the blockchain, we want to trust it, because a lot of things will happen after this. So please understand, the IoT devices are very limited from power, consumption, and the amount of algorithms that you can run on them. And the security level, the cybersecurity on these IoT devices, in majority cases, doesn't exist. So how can I trust the data that I'm getting from the IoT device, and I will put it now on a blockchain that everybody in the world will have access to it, and I will make decision based on this.
Mm-hmm.
This is the fundamental that need to be solved. How we can connect it, and there are already companies in the world working on this, building marvelous solution around that. But again, it's maturity, how to really create this chain of trust from the IoT device until we put the data in the blockchain. And this is, if you're going to use it, you need to prove why this channel is secure and the data which has been written in the blockchain from the IoT device is trustable.
Yeah, no, I agree with that. And I think as we start to evolve what the definition of PII as it pertains to, let's say, how we walk or our biometrics or our unique, did you know that every person's ear is unique and that
Yes, of course.
It's also an identifier? So as
Correct.
all those things become part of, like, say, identity, and part of how we identify ourselves in sensor technology, I think that's going to start to raise questions, concerns, and potentially more innovation in how we deal with that, so that the integrity of the system and I'd say how we protect individuals is there and is addressed. Correct.
Absolutely.
All right. Thank you, Jacob. I think that's all we have time for today. Jacob is actually on LinkedIn. If you'd like to connect with him, he is very knowledgeable in all things blockchain, cybersecurity, privacy, etc. So please go ahead and connect with him. For our audience, if you do have any ideas for future topics that you want us to cover, please contact us at communications@altitudeaccelerator.ca. Tech Uncensored is also available on podcasts, so wherever you find your podcast, you can find Tech Uncensored. I'm Hessie Jones. I look forward to seeing you next time. Next week, we're going to be at Collision, so have fun and stay safe.
Thank you very much. Bye-bye.